Okay, this is the rational function unit review. I'm going to be doing 1 or 2 maybe problems per video. Just a reminder, when you're using these videos, pause as much as you need to. Use the rewind or fast forward if I'm going too slowly for you. Make it fit you, make it work for you. Pause and try to get ahead and then check your work. I think all of those are great strategies when using these videos. I will pull up the calculator to check my work. I'm going to do a lot of it without the calculator using our algebra rules. So just to give you a heads up on that. You can lean on your calculator as much as you want during this unit. We will revisit rational functions at the end of the year and do rational functions without a calculator, kind of once these rules have sunk in. Right, the first thing we always do with any function is to factor. So I'm going to factor x minus 3 as on top of x squared minus 4. So I'm going to factor that denominator. All right, so all of these pieces matter to us. The numerator gives us our x-intercept. So I'm going to set that equal to 0. X minus 3 equals 0. Add 3 to each side. Our x-intercept is x equals 3, or the point 30. We will be able to confirm that on our calculator. We'll come back to the y-intercept later. I have 2 other pieces of information that I can get very nicely from my equation here. My vertical asymptotes come from the denominator. We're always going to write these as equations. I'm going to mark it wrong on the test if they're not written as equations. So when I set x plus 2 equal to 0, I get the line x equals negative 2. And x minus 2 equal to 0, we get the line x equals 2. The last piece that I'm going to take from this equation, just as it sits, is this. The relationship between the top and bottom. I have x over x squared, so that is a bottom heavy fraction. And bottom heavy fractions always have a horizontal asymptote at y equals 0. If we have a horizontal asymptote, then we do not have an oblique asymptote. So that's all of the information that I'm going to use right now. I'm going to go ahead and start graphing. The other thing I'm going to note is that we do not have a removable discontinuity because there's nothing that we can cancel after we factor. So I'm going to put these pieces on my graph and then go from there. I have the point 30. I have my asymptotes at x equals negative 2 and x equals positive 2. I have my horizontal asymptote at y equals 0. Now, this is a weird one in that we are going to cross the horizontal asymptote here. Clearly, we're crossing the horizontal asymptote because we have an x-intercept. It's legal to cross a horizontal asymptote, never legal to cross a vertical asymptote. I'm going to find my y-intercept. I'm going to find my y-intercept by plugging in 0 for all my x's. So if you want to think about it as an xy table for your y-intercept. And we will confirm this in our calculator as well. So that's negative 3 over 2 times negative 2 is negative 4. So that's positive 3/4. So that's y equals 3/4, or the point 0. All right, let's pull up our calculator and see what we have here. I'm going to go ahead and graph my original function, not the factored form, just in case I made any funky factoring errors. I'm going to put it in as a fraction so I don't have to worry about parentheses. Looks pretty good. It looks very similar to what I have on my graph. Now the thing that I really want though, so I can do a nice graph here, is the table. So I want a couple points on the other side between -10 and -2. None of these are really very nice. -7, -2/9 is not too bad to graph. So -7, -2/9. So it's really close here. I'm going to try to maybe see what's going on at -3 now. -3, -6. So that's just more than 1. Just more than -1, or less than -1. So -3. And that, I can make a nice curve there. Try not to press my asymptote. All right, in between my two asymptotes, I have 1 point. I'm going to find another. So there's my y-intercept at 0 3/4. And none of those are too bad to graph. So 0 or -1 4/3. And then I also had 1 2/3. So over 1 up 2/3. There's my my two errors are my asymptotes, so that's lovely. I'm confirming 3 0 as my x-intercept, and I'm going to get one more point. And all of these points are very close to 0, 8 1/12. And let's just look at the shape of that graph again, so we're sure that we're going the right direction. All right. This is a weird one because it does cross the horizontal asymptote. Still, it's going to 0 at our end there. All right, our domain here, we're going to exclude our vertical asymptotes. So -infinity to -2, -2 to 2, 2 to infinity, and that's in interval notation. In set notation, we would say x such that x cannot equal -2 and 2. On this unit test, I'm going to ask you very specifically for one type of notation or the other. On the next unit test, or after this unit test, I will let you pick. As long as your notation is good, I will let you pick. So when we're looking at range here, there is a gap. There's a gap here between 0 and the bottom of my curve. So what I want to do is just a little work with my calculator. Calc, I'm going to find the minimum of that middle curve. So I'm going to go to the left of it, to the right of it, the right of that minimum, and then guess. Oh, goodness. There we go. All right, well that did not work because of where I was. Here we go. Let's try one. Sometimes on the smartboard, my calculator does not cooperate quite as well as, especially with the scroll one. I like to scroll a lot more than I have before. To the left, my minimum is somewhere in here. To the right, and you can just hit enter again to guess. So the minimum here is at 0.654. And the other thing I want to look at is this curve that comes up above. can go back to our table maybe and see if any of these numbers, so these are all above 0. So if I go to calc and find a maximum of that curve, and this is more work than you will have to do on the test. I definitely saved kind of the nicer problems for the test and problems that take a little bit more work for the review. So I think between there we should be able to find our max. So our max there is 0.095. So when we're doing our range, we're going to go from negative infinity to 0.095, and we're going to include that point. And so that gets the bottom two curves taken care of. There's a little tiny gap in there between 0.095 and 6.54, and then we'll go from 0.654 to infinity. And in set notation there, we would just say y such that y is less than or equal to 0.095, y is greater than or equal to 0.654. All right, that's number 1. These are very time-consuming problems, but the more that you can do with the rules, the faster you will get.